Hi guys, so let's look at this proportionality. We still at Euclidean geometry, so we need to prove this proportionality. Let's say we're looking at this being A. We have A, B, C, D, E, D, E. Okay, so this theorem here says that if we have A to E, so it means from this A to E, if we divide A to E, if we divide this here, A to E, by E to C, by E to C, we should get the same as AD all over BD. Yeah, so this is what the theorem says, to say if we divide AE divided by EC is the same as AD divided by DB or BD. It's the same thing. Okay, so let's say we're trying to prove this, to prove if this theorem is true. We need to do some construction here as well, because you see it's given that these two, it's given that DE is parallel to BC. That is given. It's parallel to BC. So let's try to do some construction here. Let's say we're constructing this line here. We construct this line, and we also construct this line here. So the first step is to construct. We're doing the construction. So here we're constructing BE, and it's BE and DC. That is our construction. Okay, so we're going to use the area a lot to prove this. You see we can separate these angles here. If you look at this part of AE, B, D. So you see we're taking this part from here, so this is just this part here that we're taking this part here. So that is what we have done so far. That is what we have done in this point here. So still we can still take this this part here. We can do that as well. So that is our second diagram. So we just separated it, and then we should have AD. So this is D, AD, E, ADE, C. Okay, so that is what we have done. We just separated this. So we need to look at the area. Let's say we're looking at the area of a triangle, triangle ADE. We're looking at the area of a triangle ADE. So if you're looking at the area of a triangle ADE, so a triangle ADE, we can look at this line here, or we can construct another line. We're constructing a line between AD and E. We're constructing a line between AD and E, and that line would be as our H. So we're saying this is H1, this is H1. So we're constructing line between AD and E, a line joining AD and E, and then we're calling it H1. So that is our height. So if you're looking at the area of this triangle should be nothing but 1 over 2 times height, of which is H1, times base. In this case, base will be AD. our base would be AD. Our base would be AD. Okay, so that was the first thing to do. Also, if you're looking at the area of the triangle, so let's say we're looking at the area of the triangle DBE, that should be nothing but the triangle of DBE. So you see, our height will be outside the angle, of which will be the same as H1. So we still have the same height as H1, because you see here we have a sketch or something like this. So you should recall, maybe from the lower grade, that if we have a triangle like this, we can still have our height as that one joining there. So this is our height. So we're looking at this triangle here. We're looking at this triangle here, and obviously if you're looking at this, so our height will be the same as that one. So we have 1/2 times H1, and then if you're looking at that, we're saying that our base should be DB or BD. So that should be our base, because our base is this BD. Okay, so if you're looking at that, you can also look from this diagram here. Let's label this diagram 1 and 2. So this would be 1 and 2. So let's look at diagram number 2. If we want to find the area here of these two triangles, we need to do some construction as well. So we'll be looking now at joining D with AE. Joining D with AE, and we can call this a height, and we can label our height maybe as H2. And then if we label our height as H2, let's say we're looking at the area again. We're looking at the area of a triangle ADE, of which would be 1/2, and height is 2h. And what is our base? If you're looking at ADE, our base is AE. So our base is nothing but AE, because our base would be here. Okay, so we're looking at now the area of the triangle. We also look at the area of the triangle DEC. So that will be nothing but 1/2 times area, or times height, of which is H2, and our base, this case, will be EC. Okay, so if you try to divide this, you can just divide that and divide that. So to divide that and to divide that, so what are we getting here? You see, 1/2 divided by 1/2. So this will cancel, this will cancel. So we are left with AD all over BD, and same thing will happen here. This will cancel, and then this will cancel each other, and then what we have here is AE all over EC. Okay, so this is how we have come to this conclusion. So obviously the area, we can say that the area of a triangle ADE, the area of a triangle ADE is the same as the area, as the area of a triangle ADE, because the area that we calculated, because in if you're looking at the diagram 1 and diagram 2, it's just that you can calculate the area of ADE using this height, but still you can use this height here. So that's why I'm saying that the area is the same. So now we need to look at the area of a triangle DBE. The area of a triangle DBE, we can say the area, we're looking at the area of a triangle DBE is the same as the area of a triangle DEC. What might be the reason for that? The reasoning, if you're writing our reasoning here, the reasoning is simple because DE is parallel to BC. So the area is the same because of these parallel lines here. These two are parallels here, so they have the same base and they share the same height. Hence, we have proven what was required to say that AE divided by EC is the same as AD divided by DB. So that is how we have proved. So this will be very useful if you trying to solve some Euclidean geometry. So you will see as we go to more example. So we have done a lot of theorems. All these theorems will be used when you try to solve some Euclidean geometry. Thank you so much for watching.